Assalamu alaikum dear students. We are discussing this exercise 13.1 and the question number 27 of this is find the limit x tends to 5 f of x where f of x is mod x minus 5. For this we will find left limit, that is limit x tends to, here it is 5 negative, sorry, f of x is simply limit h tends to 0 f of 5 minus h. Now replacing x in the given equation, we in the given function we get limit h tends to 0 mod 5 minus h minus 5. So 5 minus h is positive, always positive, because h is slightly greater than 0, which implies that this 5 minus mod 5 minus h is positive, that is 5 minus h minus 5. 5 cancels, we get limit h tends to 0, which implies that left limit of this is simply 0. Similarly, right limit is mod of 5 plus h, which is 5. So it is 5 plus h minus 5. That is limit h tends to 0, and limit h tends to 0 of h is simply 0. So right limit is 0, left limit is 0, which implies that limit exists and the value of the limit is simply 0. Now question number 28, f of x is a plus bx when x less than 1, 4 when x equals to 1, b minus ax when x is greater than 1. Now if limit exists at x equals to 1 and the value of the limit is f of 1, we have to find the value of a and b. Firstly, we will find left limit at x equals to 1, that is limit x tends to 1. Negative f of x is limit h tends to 0, 1 minus h. Now 1 minus h is less than 1, so this means that we have to replace x in this a plus b x, that is limit h tends to 0, a plus b into 1 minus h, that is a plus b into 1 minus 0, because this is polynomial, it is a plus b. Similarly, limit x tends to 1 positive, f of x is 1 plus h. Now 1 plus h is greater than 1, so this means that we have to replace x in b minus ax, that is b minus a into 1 plus h, limit h tends to 0 is simply b minus a. Now here the limit exists, which implies that left limit equals to right limit, that is a plus b equals to b minus a, which implies that a equals to 0, because 2a is 0, which implies that a is 0, because limit exists at x equals to 1. Also, the value of the limit is f of 1, but f of 1 is 4, which implies that a plus b is 4, or b minus a is 4, but a is 0 implies that b is 4. So this means that a is 0, b is 4, then limit exists at x equals to 1 and the value of the limit is 1. Now if f of x satisfies limit x tends to 1, f of x minus 2 upon x square minus 1 equals to pi, it is given that this rational function fx minus 2 upon x square minus 1, its limit exists when limit of any rational function exists or quotient function exists, then we can break the limit as limit of quotient equals to quotient of the limits, that is limit x tends to 1, f of x minus 2 upon limit x tends to 1 x square minus 1 is pi, which implies that limit x tends to 1 f of x minus 2 is pi into limit x tends to 1 x square minus 1. So its limit is simply limit x tends to 1 minus 2, and its limit is 0, that is limit x tends to 1 is 2. Now the last one is if f of x is mx square plus n when x less than 0, nx plus m 0 less or equals to x less or equals to 1, nx cube plus m when x greater than 1. We have to find the values of m and n such that a limit at 1 and limit at 0 exists for this f. Now we will find left limit, that is limit x tends to 0 negative, which is 0 minus h, that is minus h. Now minus h is negative, so this means that we have to replace x as minus h in this, which is m into h square plus n, that is n, by putting h equals to 0, because m into minus h square plus n is polynomial in h. Similarly, right limit is 0 plus h, that is f of limit h tends to 0 f of h. Now h is positive, which implies that greater than 0. So this means that we have to replace x as h in n x plus m. That is, after substituting h equals to 0, we get m. Now suppose limit at x equals to 0 exists, which implies that left limit equals to right limit, that is m equals to n. Name it equation first. Also the right limit is by putting 1 minus h in given, it is n plus m, and right limit is n plus m. But we have to find the value of n and m such that limit at x equals to 1 exists. Limit at x equals to 1 exists only when right limit equals to left limit, that is n plus m equals to m plus n. Now this n plus m equals to n plus m is possible for any value of m and n, which implies that limit at 1 exists for each and every nm, and also from equation first n equals to m. This is the condition when limit exists at x equals to 0. So when we put n equals to m in the given equation, limit at x equals to 1 exists, while as for each and every value of n and m, the value of limit at x equals to 1 exists. So in this way you can find the limit of any function. Inshallah, in tomorrow's video lecture we will discuss the concept of derivative. Thank you.